Okay.
So we have two presenters today, myself, Richard Ron, and Gerard Leone, and we're going to kind of divide things up, split up the duties of talking about these various topics. And both of us have spent considerable time at Toyota. So one of the questions you might be asking yourself is, why are we qualified to talk about how Toyota does things? So we thought we'd start with a little explanation. Andreas, welcome. Explanation of our experience. Starting in, when was it, Gerard? 2010 or something like that? Quite a long time ago now.
I think it's around 15 years now, but to be frank, I lost count.
Yeah. So for more than a decade, let's say, we've been going to Toyota Material Handling in Indiana. Usually it's myself, or always myself or Gerard, and sometimes both, have been going there to teach mixed model manufacturing classes. And they've been willing to, and we're not teaching it to the Toyota folks necessarily, although we have had people from Toyota attend, but mainly it's our public workshops. So they've been generous enough to open their doors to us, to let us use their training rooms and conduct tours for our students, and also participate in Q&A sessions with our students. So it's been really a great generosity on the part of Toyota to let us come. And of course, when we're there, we both of us pay attention to what we see and make observations and make notes on what's unusual or what's working, not working. And it's really a remarkable plant by and large, right? It's, as far as I know, I mean, I have no doubt about it. It's the most, say, mature mixed model environment that we've seen.
Yeah, and part of our background is that we partner with Toyota on projects. We provide the training and consulting for some of the projects we do together, and they provide the technical expertise and the gear. So we do partner with them. However, we're not Toyota employees. We are very well versed because considering that we have been going at least 4 times a year for 15 years, 60 visits, I think it qualifies for a good degree of understanding. And much of what we teach specifically in the class that's upcoming, which, by the way, I'm going to be your instructor in that particular workshop, much of that we develop in consultation with Toyota, because one thing that we do tell people when they come to this class is that, or when they come to the mixed model line design class, is that line design at Toyota is very, very good. But where they really shine is in materials delivery. And you're going to get to see that if you come to class, because we're going to have a couple of tours and also at least one Q&A session. So yeah, we've been working with them. We've been very lucky to be working with them for some 15 years by now. So yeah, that I guess that is what qualifies us. And the fact that, as you can tell, we're both men of a certain age. We've been around for quite a long time, and I think right now we are on a year. We're way past 20 years of experience doing this. Way past.
Yeah. Well, and you'd hope that Toyota Material Handling would be good at material handling, right? So,
which kind of makes sense, and they're actually pretty awesome at material handling.
Yeah. This is just a quick shot of the classroom, awesome. One of the training facilities.
Yeah. And pretty awesome, primarily because of how they do things, not because of the resources and gear they have. And that's one of the conversations we want to have today with you.
Yeah. Okay, so let's just jump right in. Here are the topics. We've there may be more than 6, but we picked out 6 of the main things that we've noticed. And when I say noticed, I mean sometimes when we see these for the first time, we kind of, raises a question. I don't know if it's a red flag, but it raises some question of why are they doing this? Because it may have conflicted or not been entirely aligned with our previous thinking. But as we spent time there and seen all these things in action, we develop a deeper appreciation for why they do certain things. So it's not always obvious, when we see this for the first time, why these things are being done. But I've learned over the years not to challenge the way they do things too quickly, because usually they're right in terms of
their stuff does work. So
okay, so here are the 6. Focus on one-by-one flow, true mixed model production. True doesn't mean the correct way. It just means they're really mixing. True meaning absolute mixing of products. Short delivery cycles, maintaining manual processes when they can easily afford to automate just about anything they wanted, but they don't. And we'll talk about why they do that. The JIT external supply chain, meaning not when we use the term overseas, it's somewhat misleading, because some of these so-called overseas suppliers may not be actually overseas, like they could be in Mexico, for example. But I guess what we mean by external is outside of their milk run kind of zone. But they do have a lot of material coming literally from overseas, and how they manage that in small quantities. And then finally, how they consider the status, let's say, of material handlers. Are these equal citizens, or are they second-class citizens, as they are in a lot of cases? So we'll talk about that as well. All right, so let's get going. I'm going to take the first one. It's focus on one-by-one production. That the Toyota production system has a number of North Star goals. So these are goals that they may not actually ever reach, like 0 defects. Can you ever get to truly 0 defects and sustain that? Well, probably not, right? But the North Star goal is something you aspire to. And one-by-one production, or single-piece flow is sometimes another term that we use, is one of their North Star goals. But usually when we say single-piece flow, we're not thinking about raw material. We're thinking about the product flow in the line, in the assembly line. So we're moving the products one at a time through the manufacturing process. That's what we usually think of. But when we started looking at Toyota, we started realizing that they haven't given up, or they're extending this one-by-one production, not just to the work in process, but also to their suppliers and everything they do, trying to apply this one-by-one production. And certainly you're not going to get there, maybe never, on everything, but we see this effort, this philosophy of being applied to everything they do, including their material flow.
And over the years that we've been working with them, we have seen the evolution from building the masts, for example, to a small in-process Kanban, to now delivering one by one. So you will see when you come, you will see on the floor that wheels, engine covers with seats, and masts, they're all delivered one by one and every 37 minutes, which is quite remarkable. And as Richard said, will you ever get to the point at which you deliver everything one by one? No, they still have a very substantial amount of parts on Kanban. That's never one by one. But all the big stuff, they're moving in that direction of one by one delivery, and they're doing it quite well.
So we have four categories of material delivery, say, or material flow, that I wanted to show you some examples of at Toyota. We have the delivery of materials to the assembly line, or the main line, let's say. That's one category I'll show you an example of. Then we have how are they connecting upstream subassembly processes, like Gerard mentioned, some of the large stuff like mass. How do they connect those to downstream processes in one or very small quantities at a time? And then we have local supplier flow. That's the milk run kind of zone that is outside of the factory, but it's within driving distance, let's say, of 1 day or so. And then we have remote or overseas suppliers, how they deal with that. We're dealing with this last one as a separate discussion, because that's quite remarkable in itself. So bigger stuff going to the line. A lot of it, I don't know what exact percentage it would be, but probably in the range of maybe 20 or 30% would be one at a time, literally one at a time. And this is a counterweights. That's one example, but there are a lot of other examples that are delivered in the right order. So you can see these little paper tags on them, taped on them. Those will have a sequence number on it. And those are sequenced to the order of those fork trucks coming down the line. And they're going through paint, and drying and all that stuff prior to being delivered to the line, but it's literally one at a time. They may have,
Richard,
yeah.
By the way, Richard, this is relatively new information. They cast their own counterweights now.
Oh, I didn't know that.
They cast their own counterweights.
Okay.
So
all right.
the signaling is going to a foundry nearby, up Route 65, is it right?
Yeah.
Route 65 south, just 50 miles or so. The signals go there. In 10 days before, they get their signals. They set their molds. They cast. They deliver to the plant one by one. They receive like 20 containers a day. I mean, it's just an enormous number of containers a day, trucks a day. And they paint them and deliver them to the line. And being as wealthy as they are, everything is electronic, right?
Yeah.
No paper. Everything is done with paper.
So, yeah, you can see it here.
And
the interesting thing is they have a curing or drying oven, and they literally come out of that oven with enough time to cool down, I guess, and then they go right to the line. There's no big, parking lot outside with counterweights waiting to be picked up and pulled to the line.
When they install them, they're not hot, but they're warm.
Yeah, they're warm. Right, exactly. Side comment too. Over the years, since you mentioned they're casting their own counterweights, over the years, the other thing we've seen is they brought more processes in-house over the years, right? Yeah. For example, during the 2008 economic downturn, they had a policy of not laying off any permanent workers, and so clearly, if demand was way down, what do we do with all these people? So one of their strategies was, let's bring more work in-house for our own people. And one of the things they started doing in-house was building their own hydraulic cylinders, which is not something you would normally think of as taking on. But they did. And so they're building their own hydraulic cylinders. And they found that not only did they reduce the cost internally, they kept their own people busy, but the quality was better than going outside. Yeah. So interesting thing. And I guess counterweights might be another example of that. So they become much more vertically integrated, as time goes on, bit by bit. All right. So this is a simple example, but there are many dozens of examples of how they're delivering those kind of parts to the assembly line. Next one is sequence delivery custom cart. So how do you connect upstream? Well, in some cases, it's literally one at a time. And those are especially the big, heavy, parts that take a lot of floor space.
Counterweights, engine cover, seats, wheels, that stuff.
Yeah. But there are other parts that are maybe not as big that they still want to flow one at a time, but they want to do it maybe a little more efficiently. So they've developed quite a few of these customized carts that will store sets of parts. So in this case, I can't tell you for sure, but this might be a set of two, right? You need two of these per fork truck, for example. And they'll load these carts upstream at the supplying feeder process and then park them next to where they're going to be consumed, but in sets of maybe 4 units at a time or 8 units at a time, typically some round number like that. And then the cart itself is the signal, right? The cart itself is like a Kanban cart. When that cart is emptied, then it will be picked up and returned to the supplying internal feeder process to be refilled and brought back. So there's cycling.
I think it's fair to say that they're very, very good at much of what they do, but they're masters of simplicity. Everything that they can do simply, they will. And, a cart, refill it, simple, do it.
Yeah. In fact, along those lines, they're relatively conservative in terms of the use of technology. They do have some AGVs that are running around, but it's typically an AGV situation where you're going back and forth, like in a very repetitive way. I haven't, like, for example, engine prep, and then the engine goes right to the line right next door, right? So a lot of going back and forth that was fairly straightforward to automate. But I haven't seen a lot of automation of material handling from different parts of the factory. This may be different in automotive, but at least at this factory, it's still a driver, right, driving these around.
Yes, there are a few cases of AGV implementation, and of course they will continue implementing. And the funny thing is that whatever we tell you today, next time we go, there will be something better. I remember that they started implementing the movement of masts using AGVs. And that's something that, from one visit to the next, all of a sudden we started seeing that. So they do take Kaizen and continuous improvement very seriously, and they're constantly improving.
Yeah. Andreas has a question, by the way. Can you say something about process reliability? Well, clearly, if they didn't have highly reliable processes, this whole discussion wouldn't work very well, right? Because you'd be sequencing material, and then you'd have a bad part. And that could cause things to come to a screeching halt. So they have a extremely robust process in place for the last 30 years, probably or more, of when a defect occurs in the line, they track that like a bloodhound, right? They don't let up on fixing those issues, should they occur. So they don't happen very often, I guess, is the answer.
Well, it depends on who you ask, right? You ask us, we'll tell you what you'll see is remarkable. The level of reliability is out of this world. You go ask them, and they will tell you, oh, we have problems. Because they do find defects every now and again. As a matter of fact, they have a small hospital where certain trucks are diverted to be fixed. But a truck is there for minutes or hours, and no defect goes unresearched. They have a board in the hospital, and in that board, every defect is documented, and the action behind it to figure out, or the countermeasures, or figure out the solutions, or figured out. Everything is on that board, and that truck is not, even if it is fixed, is not released until that board says, yep, we know how to make sure this doesn't happen again. Truck can go. So from that standpoint, yes, they will tell you, oh yeah, we find defects, but very different to what many of us do with, I found a defect, I polish it up and let it go as quickly as possible. They did.
And they have a robust end-on system as well. So if something happens, a cord gets pulled or a switch gets flicked, and they have a very disciplined response process. So first level response might be the team leader immediately, and then if that can't be resolved within a certain time frame, then you'll have the next level, supervisor, engineer, etc. So they're very quick to respond because the line is moving, right?
You're rarely on the floor, and an end-on light is not going. And for those of you who come to class, when we take you on the tour, keep your ears open for the music. The annoying little music, ding, 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 ding. That means someone pulled the cord all the time. It's just remarkable.
Okay.
Yes,
do they have a documentation
process? Yes, I see another question. Yes, they do have a documentation process, and it's very simple. It is a board. Everything is based on the board, and of course, then each department that participates in the escalation process have their own documentation.
Okay. Then we're still talking about this single piece flow. So another large percentage of their parts come from that are not produced internally are coming from domestic suppliers within quite a wide geographic range, I would say. I was surprised at this. You can see the circle I drew on the map here. So right in the center is more or less where the plant is. And their milk run trucks go up to southern Minnesota and down to northern Georgia. And this is on a daily basis. I think they have something like 12 different routes, at least last time I was there. And these trucks are owned by Toyota. So supplier does not pay for freight unless they miss the pickup, in which case it's on their own nickel. But these trucks will go out and bring back recyclable containers, usually empty, and then pick up the full ones and bring them back. And of course, there's a robust communication that's happening between the factory and the suppliers, because usually what they receive is not more than a day's worth of parts. So really true JIT, I would say.
And if you were to ask us to work with you, right, Gerard, Richard, can you send the team of Leonardo Group folks to work with us in a consulting capacity? This would not be priority one. This is something they achieved over decades of improvement. So this is not priority one, but as you can tell, it is possible, and they do it. They receive small quantities every day from multiple different suppliers. Yeah, and they engage the suppliers and they support the suppliers. So it's another remarkable thing they do.
Yeah, so it's not something you can do overnight. They have dozens of suppliers that they've worked with closely, and typically the suppliers have a long-term relationship with Toyota. So they clearly understand what the expectations are for delivery and quality, right? And they meet it. So, but it's quite a remarkable thing in itself that when you look at their inventory levels, the amount of purchased material that is coming from this supply chain is not more than a day or two worth of material, which is not a lot, not very much, right? Not a lot. Becky, to your second comment, any kind of defect that they uncover on the factory floor doesn't fall off the board for 90 days as part of their process. They don't let it fall off the board until they're darn sure, right, that they've addressed the root cause, and it's not going to happen again. So they may have a temporary fix for an issue in order to keep the line running.
Countermeasure.
But a countermeasure. But until the root cause is uncovered and they have a permanent fix, they don't let it drop off the board. And even after that, 90 days to verify that it's going to stick. All right. The last thing was outside suppliers, but we're going to talk about that as a separate issue. So let's go on to the next topic. Gerard, you're going to take the lead on this one. True mixed model production.
Yes. When you observe their manufacturing line, and again, now I'm going to go back to their final assembly line, you will see that they actually do mix. You will see, and on their main line, they actually have two main lines, one of them for the big product, very low volume, long takt time. But for the main line, which right now it operates at less than 3-minute takt time. Think about a Ford truck, less than 3-minute takt time. That's a feat, 2:45 to be precise. That's a feat. And what they do to mix, and they mix electric and internal combustion on the same line. And what they do to mix, their primary mixing methodology or balancing methodology at the main line is work content time. So what they will do is if they send a fully loaded unit, it will be followed by 2 plain vanilla units to constantly manage that time and make sure that if you slow down because you send something with high work content, then you speed up because you send something with lower work content. Their level of balancing is very, very refined. Again, that's not something that many companies can achieve. But yes, they do build one unit at a time, and they lock in production. They lock in the plan 2 months ahead, and they lock in the lineup around 2 weeks ahead. And for that, given the fact that they have such a long portfolio, then they can really do a lot of production balancing, of production leveling. So they do maintain that level of leveling, and that communicates back upstream. And upstream, they have other methodologies like, color, not only work content, color, size, etc. And that's how they maintain one-by-one production. They really do take it seriously, and they live by one-by-one production, and they do use the term mixed modeling.
That's kind of an unfair advantage that they have, in that they've got a 60-day or so backlog that they try to maintain.
is longer now. After COVID,
Yeah.
it got really long, but they're trying to get it down back to 60, as you said, Richard.
Right. So at least for a while there, they were trying to maintain a 60-day backlog, which is within the lead time from Japan, right, from a lot of their parts. And many of you probably watching this don't have that kind of luxurious situation of 60 days worth of orders. And then, of course, as that backlog would grow, they'd have to reduce it by adding capacity. So they've done, I don't know what, Gerard, 14 plant additions or something since we've been working with them, or more. I don't know.
Yeah, Tom talks about that during his presentation. But yeah, I think it is that high number. I think they're close to 2 million square feet now.
Oh yeah, so that's the size of it. But that, not everyone has that luxury of being able to draw on a backlog and then place orders overseas with an order based on orders in hand. That's kind of a luxury.
that should not prevent you from doing a better job at production leveling, right? You may not have months, but it doesn't mean you have only hours.
But I think the message here for material flow is that every unit coming down that line has at least some unique parts, right, that are only being delivered for that unit, and they're able to manage that without a hiccup. Be able to deliver those custom items. The customer is allowed to specify quite a long list of options, and all of those have to be managed. They have to be procured, and then they have to be physically delivered to the point in the line where they're going to be installed. So you can imagine they do it very well, but it's not a minor detail that they're managing to accomplish. Okay, so this is just some examples, Gerard, of the amount of components.
The number of base models is not particularly high, but once you put all the options on top of it, it is a maze. And the way they manage that is manually. They have they call it the grid, which is basically an Excel spreadsheet, where they have all their models and the dates and the capacity per model and option, and then basically they consume them. Once they consume, planning knows, okay, I'm done. That's it. They consume the bucket, I'm done. The relationship with planning is between operations and planning is just remarkable. There is no animosity. There's only partnership there. So yeah, they do mix a lot, even though they all look the same to the untrained eye. They have a lot of models.
And this fork truck in the picture was one that we happened to be seeing, as it was going through the line. What you're seeing here is, I think it's just a final quality inspection.
Yep.
At the end. But this particular unit was one that they created for their own internal use I think it was the 50th anniversary.
Yes, and right now that one is on display on the rotunda.
Right. Yeah, but we happened to be there at the time that it was going through.
And they have another one dedicated to veterans, because they employ quite a few veterans, and the names of all the veterans that work for Toyota are printed on the counterweight. Yeah.
All right. So let's go to the next topic, short delivery cycles. So what we're talking about here is how often do they deliver parts to the line, right? Based on a schedule, right, or a fixed cycle. So it's not just when people raise their hand, we bring them the parts. They have a schedule, like a streetcar, right? So the streetcar or delivery routes are designed, ahead of time, and the drop-off points are all designed, et cetera, et cetera. So I remember, Gerard, when you and I first started working together back in the 90s, right? If you correct me if I'm wrong, our rule of thumb for how much material do we want to store on the line? If people asked us that question, it would be, we had a formula, right? It was 1 day on the line, 3 days in the supermarket, 10 days in the warehouse.
Yeah.
So 1 day. So in theory, once a day, you could restock the line, right?
And I tell you, for many of you listening to us that may not have a very mature material system, I wouldn't be too upset if you were to tell me we're going to start with one 1 day of inventory at the line and be disciplined about maintaining that, I would say, you know what? You're good.
Could be less than you have now, right? One day could be less than you have now.
Yeah, remove the pallets and the gaylords, go to 1 day in a container. I'm liking that.
Yeah.
But
now,
these folks have been at it for a while.
Yeah. And the other thing, though, that struck us as kind of strange initially, it struck me as kind of strange, was that we always had this feeling or this philosophy that material handling was waste, right? It's muda, it's non-value adding. So whatever you can do to reduce material handling, that was a good thing, right? And when we started looking at the line at Toyota, my first thought was, boy, there are a lot of people driving tuggers around, a lot of material handling going on. This is kind of challenging my thought that, material handling should be reduced as much as possible because it's just an added cost, right? It's not adding any value. The value is added by the operators on the line building the product, but everything else is an overhead kind of function. And I'll cut to the chase. The cycle time, the designed delivery cycle time at Toyota, I don't know what it is now. Gerard, you were there most recently, but what I remember was around the range of 35 minutes.
37 minutes. Ding,
yeah,
ding,
37
ding,
minutes. Yep.
37 minutes, which is calculated as the number of effective minutes divided by 12.
12.
Why
right.
12? Why 12? Well, it's that's if we told you that's a mystic number.
No, Oriental inscrutable philosophy.
Exactly. Not really. It is basically a number that allows for the highest number of multiples. 12 is divisible by 1, by 2, by 3, by 4, by 6, by 12. And that allows for more sequencing cycles throughout the day. I'm going to have to leave it at that. If you guys have asked any questions on that one, we're going to go over 1 hour. But that's basically
okay. So 37 minutes.
37 minutes, folks.
Yeah, which is not so. In other words, to say it in plain English, every 37 minutes they're going to be running one of these delivery routes. They have quite a few of them.
12.
Yeah, 12 delivery routes. So 12 again, right?
Yeah.
So for that reason, when you observe the line, you see these tuggers, with carts behind, driving around pretty much all the time. So
picking up empties, delivering fulls. Yeah.
Right. Now, why would you want to do that? Well, the pros of a short delivery cycle are, well, then if you're replenishing every 37 minutes, then the amount of material that you need to stock at the workstations can be much less. And that was one of the goals. Not stock a lot of material at the stations, smaller bins, right? Less shelf space required. That's definitely a positive. And that will impact operator productivity as well. Right? They don't have to move or walk a longer distance because it's whatever they need is in a small bin right in front of them.
And something goes wrong, you can recover very quickly.
Well, that's number 2 there, risk of part shortages, right? So if something goes wrong, you do have, to Andreas's question, you have a bad part or something, you can rely on a regular routine replenishment in 37 minutes, just like a streetcar schedule, right? Even if you miss the streetcar, you kind of figure, well, it's going to be no more than 37 minutes and probably less that a cart will come by.
I'll still make my meeting.
Kind of ties, yeah. So number 3, more flexibility in responding to if the schedule changes, you're able to, adjust your replenishment of parts and respond to that more quickly. Then, of course, space, we already touched on that, is significantly less than it could be if you were stocking a day's worth, right? It's going to be 12 times less, theoretically, right? Now, there are some downsides that we've already touched on. The cons of short delivery cycles is you're going to have more labor, right? More material handling labor, I think, inevitably required to maintain this 37-minute cycle. You have more material handlers, most likely. And a lot of companies we work with, that's kind of a hard pill to swallow, is adding more material handlers.
But it's mostly based on the consideration that material handlers are indirect. We do not want to increase indirect.
Right. And then you probably have an additional demand on material delivery equipment. So we're talking about fork trucks and carts and tuggers.
Tuggers.
Yeah. Yeah. But anyway, this is what they're doing. And it was initially a cultural shock a little bit for me to see that in operation. But I've come to appreciate, how effective it is. And I guess the saying is the proof is in the pudding.
Yeah.
The proof is in the pudding. And the pudding is that Toyota Material Handling is in some cases wildly more profitable than any of their competitors.
And their inventory turns
yeah.
are out of this world. If you're hoping to be in the 15 turn a year club, these folks in some cases reach the 3 digits. So they are. Yeah. I knew someone was going to ask about the 12. The reason why they take the entire day and split it into 12 cycles, and that is the 37 minutes, their one shift divided by 12, is because 12 number of cycles is, again, divisible by 1, 2, 3, 4, and 6, and that allows for more cycles of sequencing. You can sequence every once, every 2, every 3, every 4, every 6, or once a day. That's how they do it. And again, this is as far as I can go, and that's why they chose the number 12. And they get that question so much that they are the ones joking about, well, this is secret knowledge we got from ancient aliens or something like that.
Okay, so this is a map of how they actually do it. They have a number of different locations, like storage locations in the factory floor for different types of material, but they all come together in what they call a baton touch. Baton like a race, right?
Like a race, like a
relay race,
like
where your hand is off. So the idea is you have these different areas handing off materials based on the schedule, and they have what's called a decoupled delivery method, where the tugger driver driving the actual tuggers and carts is not the same person that's doing the picking and organizing of the material in the baton touch area. So the tugger driver will literally come over to the baton touch area, disconnect the empty carts, hook up the next cart that's waiting, and take off and start the next delivery cycle.
Yeah. If you look at this picture, the bottom is a cycle, the delivery cycle. The top is another cycle, another loop, and that is the replenishment cycle. You pick up here, you assemble in the baton touch area, which is basically a parking lot with all the tugger trains, and then you deliver every 37 minutes. So the folks at the top, the pickers, have 37 minutes to assemble a train. The folks at the bottom here have 37 minutes to deliver to the workstations in their route.
Yeah, I said 35 here. I wasn't sure what the latest 37. Number was, but yeah, I was close enough for government work.
Close enough, yeah. Plus, it used to be 35, not 37.
Yeah. Okay. Manual processes.
Oh, this one is really interesting because, again, they are a wildly profitable company. They are very wealthy, yet they are extremely cautious about automating, to the point that sometimes my substantial jaw drops to the ground thinking or asking them, what? You did not automate that? No, don't see the value. One example, Kanban cards. First of all, they still do Kanban. Quite a bit, as a matter of fact, less than they used to. When we started working with them, they were around 75, 80% Kanban. Now, less. They're probably in the 60% Kanban, so still very Kanban intensive. The bins they use, they are standard gray Acro bins. They're all the same. The bins have a no identifiable feature. It's just the bin. Bins are generic. And each bin has a Kanban card, paper Kanban card. And those Kanban cards are collected every 37 minutes, delivered to a scanning office every 37 minutes, reprinted or retained every 37 minutes, picked every 37 minutes, delivered back every 37 minutes manually. And again, we ask why. And many of our folks that come to class, that question always comes up in the Q&A sessions. And the answer is we just don't see the value. We just don't see the value. And it is remarkable. And probably one of the cons is going to be, for you to consider is, well, what if the cards get lost? Well, they do have a bit of custom software that they don't reveal exactly what's in it, that scans all the cards, right? The cards get to the scanning office, they scan them all, and it has intelligence that says, hey, wait a second, such and such card should have arrived by now. And it prints an exception list. You go research and see if a card has been lost or a bin is out there without a card or something happened. So, manually. And everything that gets sequenced to the line has a sheet of paper plastered on it saying this counterweight is bespoke for this product, this order, in this sequence. And they're all aligned. And trust me, counterweights is not something that you can say, okay, I'm going to change this one for that one, right? They are aligned and they have to remain aligned. So they do manual processes because they are just, I guess it's that they're prudent with their automation dollar. And I don't think it's a matter of money, because it's not like they don't have it. It's just a matter of what works.
One other thing, Gerard, I think with the use of manual Kanban cards is they didn't want to disconnect the operators from that process. They could easily automate it, so you don't have to worry about your bins. It all gets replenished, signals for replenishment automatically. You don't have to worry about it. But they wanted people to worry about it. They wanted the operators to be paying attention, right? Picking a card and putting it in a bin and looking at, what's going on in front of you and looking at the bins getting empty. They didn't want to disconnect the operators from that level of responsibility. Engagement.
That's very true. Yes.
The other thing that I'll mention is when they do the scanning of the cards, every one of those paper cards is serialized, right? It has a barcode on it. So if one of these cards gets lost, I think you mentioned this already, but it doesn't, it wouldn't get scanned. It wouldn't get returned. And therefore a flag can be raised very quickly. And this is part of their secret sauce, right? Their secret software. But I don't think the secret's very secret because it's not that hard to think of how that might work. But that's what they're doing. So they have a very robust follow-up, in other words.
Yeah.
They don't just let the Kanban system run and hope it works. They're following up pretty quickly if they think that there's a problem with it. Right? They have people go physically on the floor and find that bin, right? Where is that bin? Because that card should have been scanned already.
Yeah.
And they have human beings going out and finding out what happened.
Yeah.
All right. I think I have a picture. Yeah. So here's not much to know here, but there's a barcode there, right? This is a Toyota Kanban card.
Yeah.
And these are printed. These are not recycled. These are one-time use only, right? Yeah. And they're put in the bin with a unique identifier there in the barcode. And when they're returned, they're scanned and then destroyed, right? And reprinted.
Yeah. Reprinted. Well, we'll get into that later, but there is some intelligence there that says, hey, this part will not be consumed within this much time, retain. Oh, this part is going to increase, print to. So they do have that intelligence in the system.
Yeah, I'm noticing here, we'll talk about that here in a minute, but it says supplier name Takahama, which is their Japanese factory.
Mm-hmm.
The mothership for Toyota material handling over there. So they have quite a few, parts like that, imported parts.
Yeah.
And here's the system.
And that is the opposite loop. If you look from the line at the bottom, cards get accumulated by the crew lead into a box. They call that the child box. Then by the group lead into another box. Then they call that the parent box. And these are paper cards. And then that stack is collected by the tugger driver, dropped right there at the center at the scanning office. They scan them, and then based on some intelligence, whether or not that part is in the planning horizon, will be reprinted, retained, increased, decreased, and sent out to any of the areas where they are to be picked, assembled into a train, delivered back. So
also,
that's how they do it.
If the cards don't get picked up or don't get placed in the parent box, then clearly they won't get picked up, right? Then they won't get scanned, and then you missed a cycle, and that could be a problem. Yeah. So they have a kind of an and-on system set up that tracks if the cards are in that collection box or not, with some lead time prior to when that tugger is going to come by, and they'll actually follow up with the team leaders. Hey, where are your cards, right? Because this is happening every 37 minutes. So it's quite a thing to see.
As a matter of fact, every 37 minutes, a voice comes over the PA system saying, line leads, pick your cards.
Yeah, reminder.
Reminding them, line leads, pick your cards, yeah.
Yeah, I mean, the lesson is not too many of the things they do are just simply left to chance, right? Even if they're designed well to begin with, there's just a lot of follow-up and
backup. If you're not there to do it, then who's going to do it? And for that, I recommend, folks, that you get a copy of an old article from the Harvard Business Review called Decoding the Toyota DNA. And the article is great, but there's a little box in the article, that to me is worth more than the entire article. And that speaks to the process design at Toyota. And the first line, if my memory serves me well, is every process has a backup. Every process has a backup. So if you're not there to pick up your cards, who's going to do it for you? That person steps in and helps you out.
Great, thank you. Okay, JIT external supply chain. So these are suppliers that are delivering parts outside of the milk run that we looked at earlier. So it could be from Japan or overseas. It could be in the U.S., but maybe from California or some places farther away. Now, I know they make a strong effort to get those suppliers within the milk run, range, for sure. So I can't tell you what percentage of parts are U.S. but coming from outside of that milk run scenario. But what they're doing here, specifically with the parts from Japan, because the lead time is about 50 days, if I remember. I mean, they have to get produced in Japan. They have to get shipped to the dock. They have to get put on a boat. The boat has to go across the ocean. They have to clear customs in Seattle or LA or wherever they arrive. Then they have to get put on a train that goes to Chicago, and then they get put on a truck that gets delivered to Columbus, Indiana. So that's 50 days, right? So they can give Japan the mothership that produces, by the way, some of the high ticket items, transmissions, engines, stuff like that, come from Japan for the most part. So so how do they manage that without having a lot of inventory? Because that's a lot of risk, right? It's 50 days, and especially since COVID has happened, that's kind of raised concern with a lot of people. I'm sure you've heard this of, does JIT work anymore? Is JIT possible in this world, post-COVID world, where supply chains got messed up? Well, when Tom Lego, who's our Toyota ambassador, was asked that question, he just laughed. He was asked that by some Toyota folks as well. Gee, are we giving up on just in time? After this COVID stuff, are we just giving up on just in time? And he laughed. He said,
"No,
that'd be
like
Christians giving up on Jesus."
Yeah.
That's a core of the Toyota system. So no, we're gonna make it work, and they had some workarounds, right, to survive that era. So there's some challenges. You've got transportation costs from far away. You've got the whole lead time issue. You've got the flexibility issues. What if something changes within the 50 days? All those things have to manage. But the biggest benefit is if you can get it to work, then you're going to radically reduce your raw material inventory, purchase parts. So working capital, the investment you have in space and in money, it can be greatly reduced if you can execute this. So here's a picture of kind of what they're doing here. This is a summarized example of part of our class that we teach at Toyota. But the idea is this: if you can mix parts in a shipping container, different parts in the same shipping container, what you can do is reduce the quantity of any given part without actually increasing the number of shipments. So if you look at this color coding here, I could ship all of the A's on Monday. I could choose to do that. And I could ship all of the B's on Tuesday and all of the C's on Wednesday, et cetera. But I would be shipping a week's worth, right, of the same item in the same container, and I have to store them. When they arrived at the other end, I'd have to store a week's worth of parts and then gradually consume those during the week, correct? But if I can mix A, B's, C's, and D's and E's into the same shipping container and do that every day, then the amount of inventory I would have arriving at the other end is going to be much smaller for any individual item. Now, this is not a new concept. Lots of companies are doing this. John Deere, I know, is attempting this. But it requires you to be able to, number one, have a kind of like a cross-dock function on the shipping end, right? There has to be a function to take all these different parts and combine them into a shipping container and send them. And then on the other end, you would have to have a unpacking function, right, where you're opening up these shipping containers and unpacking and putting away. But this is exactly what they do. So they have virtually daily shipments from Japan with a mix of parts in the container, not just one container, but I think they're receiving like 6 to 8 shipping containers, the 40-foot containers, every day, 6 to 8 a day. And then they get opened up and there's a put away, and this is a mix of parts that they're receiving. As a result then, and I was floored when I heard this, I asked the Toyota folks, well, what's your inventory in terms of number of days of these imported parts from Japan? And they said, well, we try to keep it down to no more than 2 to 3 days of inventory, which was like, what? But and assuming that they're not lying to me, right? This is like extremely low level of inventory. And this is one of the reasons why they're so profitable, right? If they're able to execute that, they don't have literally millions and millions of dollars of unneeded inventory, since they can execute. So this is basically...
If they need to increase inventory, they will. And they will tell you very clearly. They're not allergic to inventory. If they need it, they'll increase it. And when a supplier has a problem, yeah, they will increase that amount of inventory. During COVID, they increased inventory. But they relentlessly drive towards optimizing. I don't think the right word is decreasing, is optimizing inventory to make sure that the line never stops and they always have the right thing. And they do a lot of planning. That's
a lot of planning. So just picture a tube or a pipeline going from Japan from their mother factory to Indiana, and they're feeding that pipeline with a mix of parts every day, and they're taking parts out of that pipeline every day, and it's just flowing like that. Now, clearly they had some challenges during COVID. For example, getting them off the ships and stuff like that. Oh, yeah. And I'm sure there's a story to tell about that they could share with us. But we'll leave it at that. This is basically what they're doing, and it seems to be serving them extremely well.
Okay, Richard, we're within 5 minutes of our promise.
Yeah, one more. Last thing.
Last one. Material handlers at Toyota Material Handling, at Toyota Industrial Products, are considered direct. They're not indirect. Everybody on the floor is a direct employee. So when you see at some of your plants that, well, we need to get a material handler to do this because they're cheaper, basically you're not treating them on equally as you treat an assembler. Not at Toyota. Everybody is the same, gets paid the same. Everybody's direct. And it works for them. And they get this question every time we have class, right? During the Q&A sessions. Why Well, because in that way we're all contributing the same. We're all looking for ways to eliminate waste. Everybody is. If I am considered 100% waste, well, what's the point, right? But if my job is value added, then I start looking for those elements of waste that I can improve, and they do this masterfully.
And having formal delivery routes and formal processes that can be standardized and timed allow you to actually staff correctly. I mean, one of the most common questions we would get in the past was, from our clients would be, okay, well, how many material handlers do we need? But the answer's got to be, well, what work are they doing, right? And how long does it take? If you can't answer that question, then you have to rely on some kind of formula, right? Or percentage of direct workforce.
Some kind of a table, some kind of a guess based on experience, which, by the way, when you come to class, those of you who come to class, we will talk about calculating number of resources for the delivery routes.
Okay, so I think we're coming near the end, right? Yes. So little commercial here. The next workshop, which Gerard will be teaching, is coming up in about 8 weeks on October 31st, November 2nd. This is the material class. So the same subject we're talking about here. The difference is we're going in a lot more depth into each of these subjects. And you get to go out on the factory floor with Toyota experts. And there are two tours included in the workshop, in the 3-day event, where you get out there and get to see all of this in action. So highly recommended, and suggest that if you can get to attend it, you won't regret it. In fact,
please join us.
It's going to stay with you the rest of your life, probably.
We have
that experience.
We have very few seats left, by the way. So, so if you're planning to come, sign up, because I think we're going to be closing registration within the next couple of weeks. In 3 days, as Richard said, tour and also Q&A session with our host, Tom Lego, and that is, 100% Toyota. So come in with your questions. You're going to be delighted. You're going to be glad you did.
Yeah, so you can see it on your screen, I think. There's a link to the information page with, the detail of exactly what we'll be covering and how this will work and how to sign up. But that's there. I do have a copy of this presentation that I'll put on the screen. It's just a PDF of these slides. If you want to download that, you can do that. You should be able to see that on your screen. So that's it, huh? I think we've reached
I guess
the end of our journey here. It's 11:59. Yeah. No matter how hard we try, we still take an hour.
Yeah. And if we didn't cut off, we would take 2. So
in case you're wondering, this is a Dali, a piece of original artwork done by AI. I'm getting a personal kick out of using it. So I asked us to give us a material handler with a happy look on his face and a cart full of parts in the style of Salvador Dali. And this is what we got.
He more than happy. He looks like he had a little too much coffee.
Blissful. Yeah. Okay. There was one other question too. Bobby. Yes. It's called Telecaster Custom 72.
Yes.
With one humbucker.
With humbuckers. Oh, the man knows.
Yeah, there we go. Yeah, he knew.
Yeah.
Yes. Okay, so I think we're done, folks. Thank you so much for attending, and we'll see you at the next one, hopefully.
Next time, Richard will have his Stratocaster in the back. Okay, yeah. Bobby?
Yeah.
Or maybe his ukulele. I don't know. We'll see.
Yeah, a different instrument for every webinar. Name the instrument. See if you can identify.
Name the instrument. Sounds good, everybody. Thank you for your time, and we'll see you next time. And I hope to see you in Indiana.
Okay. Bye now, everyone.